Hello, ladies and gentlemen. You once again have the hands of habits. Glad to be back with you. Okay, we are starting a new topic today called graphing linear inequalities. And before we get into that, I just want to make sure that you are remembering how to solve plain old regular one-dimensional inequalities. So if you will look at this inequality right here, and if you will just draw your wall through the symbol there and go ahead and solve your inequality for x. Okay, now that you have solved for x, if you did get the wrong answer, I'm going to put the correct solving in here just to let you see it. So if you did get the wrong answer, go ahead and pause right here and look at the work until you make sure you got that correct. So our answer is x is less than 11. So let me write that down right here. X is less than 11. So if I come over here to the number line and I'm going to graph that, I'm going to put the number 11 kind of in the middle of my number line, and I'm going to fill out the rest of my numbers. 11, 12, 13, 14, got 10, 9, 8. All right, so I'm just going to make a number line with my solution in the middle. Now, I don't just have one solution because this is an inequality. I have many, infinite number of solutions. Every x that is less than 11 is a solution. It does not include 11. So if you remember from the warm-up that we did, if I have an open circle, that is related to less than or greater than, but not including the point. If I have a closed circle, that's related to less than or equal to and greater than or equal to. So in this case, I've got less than 11. So I'm going to put an open circle around 11, and my solutions are all the numbers that are less than 11. So those are the numbers to the left. So I'm going to do my little graph like this. So this is indicating that everything to the left of 11 is a solution. So any number to the left, if I plug that into this inequality, it should make this inequality true. So let's try it. Let's try one. So anywhere over here, if I pick the number 9, and I plug that in for my x, 9 is less than 11. Is that true? Yes, it is true. So therefore 9 is a solution. So we graphed it correctly. Okay, so the only thing you got to remember when you're solving inequalities that's different from solving equations is what? That's right. Let's go ahead and write that down. If you multiply or divide by a negative number, or divide, I'll do the little dividey symbol, by a negative number, I'm going to do number sign, flip the symbol. Okay, so that's a rule we learned a while back. So that's the only difference. Now, solution, let's go ahead and define what that is. A solution is any number or numbers that make an equation or inequality true. Okay, so solution is anything that makes it true. Okay? So let's go down to, now we're going to do graphing linear inequalities, and I left a word out right here, so let's just go ahead and put linear in there. Okay, we've been doing single dimension inequalities. Now we're going to do inequalities in 2 dimensions. That's linear. So it has to do with inequalities of the formula y equals mx plus b, if we change the equal sign to an inequality symbol in slope-intercept form. Okay, so I'm going to go through what the steps are for doing this. So let's write the steps down and then we'll practice. So the first step is to solve for y. So if my inequality doesn't have y by itself, we got to solve for y so that we can tell what the slope and y-intercept are. The second step is to graph at least 2 points, using the y-intercept, which is the b value, and the slope, which is my m value. So that's my m value. Okay? So we're graphing 2 points using the slope, using the y-intercept and the slope. Okay, step 3 is we have to determine whether our line is going to be dashed or solid. And you'll see more what I mean by this in a second, and then we're going to draw the line. Okay? Dashed lines are for these symbols, less than or greater than. If it's less than symbol or greater than, you're going to use a dashed line. Solid line is going to be less than or equal to or greater than or equal to. And you can remember that because it has a solid line under for equal, and that's when you make the solid line, is when it has one of those symbols. Step 4 is we are going to shade up if I have a greater than or equal to symbol, and we're going to shade down if I have a less than or equal to symbol. Okay? So those are my 4 steps. Now let me show you what that is actually going to mean. All right, so here's my example 1, and I'm going to follow those 4 steps. So my example 1 says to graph this inequality. So notice I have an x and a y this time. So my first step is to solve for y, so I can get this into y equals mx plus b format. So let's go ahead and draw our wall. And I want you to go ahead and solve for y. Okay, so when you solved for y, I am hoping that you ended up with y is greater than 4x minus 3. Okay? So that's your inequality. That's your linear inequality. Now, using the slope and the y-intercept, remember, this is now in the form mx plus b over here. So my slope is 4. My y-intercept is negative 3. So I'm going to use my y-intercept first. We're on step 2 now. Graph 2 points using the y-intercept and the slope. So my y-intercept is negative 3. So I'm going to come down here and I'm going to put a point at negative 3 on the graph. Now I'm going to use my slope to graph another point. So my slope is equal to 4, which if I write that as a fraction, that's 4 over 1. So that means go up 4, and then it means go to the right 1. So from the y-intercept, not from the origin, from the y-intercept, put your pencil there, you're going to go up 4, and remember you're counting the lines, not the spaces. So we're going to count 1, 2, 3, 4, and then over 1 to the right. And that's already 2 points, but if you want to make your graph really accurate, you can do that again. So I'll do it again. 1, 2, 3, 4 over 1. Okay? Now I've graphed some points. Now let's go to step 3. If my symbol is one of these, less than or greater than, I'm going to pick dashed line. If it's one of these, I'm going to pick a solid line. So my symbol in this inequality is greater than. So I am going to pick my dashed line. So come down here and we're just going to make a dashed line through all of these points all the way across the graph. And I can put arrows on either end because lines go on forever. Then I'm ready to do my shading, my last point, or my last step. So I'm going to look at my symbol. It is a greater than. Greater than means I shade up. So when you're determining which way to shade, I'm going to put my pencil on the y-intercept. This is kind of the way I've found it to be easiest for me. I'm going to put my pencil on the y-intercept, and if it's greater, I'm going to shade up from that. So I'm going to shade this whole side of the line, everywhere above the line, because I had a greater than. Now what this shading means is this is the solution area. It means every point in this shaded area is going to make this true. It's going to make this inequality true. So in order to test that, we're going to test a couple of points. So let's write down our original inequality. So I have negative 4x plus y is greater than negative 3. Now I'm going to pick a point that is in the solution area, and it should make this inequality true. So the easiest point to pick for me is the origin. It's the point 0, 0. So if I pick the point 0, 0, remember that's x equals 0 and y equals 0. So let's plug that point into my original inequality. So I'm going to put 0 in for x, and I'm going to plug 0 in for y. So let's see what we have. We have negative 4, and I'm going to plug 0. So negative 4 times 0 plus 0 is greater than negative 3. Now remember, this is inside of our shaded area, so this should make this true if we did it right. Negative 4 times 0 is 0, plus 0 is greater than negative 3. That is 0 is greater than negative 3, and is that true? Yes, that is true. That is a solution. Now that should be true for any point in our shaded area. Let's pick a point over here outside of our shaded area. So let's just pick the point 2, 1. So here's the 0.21 right here. So let's pick that point, 0.21. This should not work because it's outside my solution area. So here's my x, here's my y. Let's write down my inequality again. Negative 4x plus y is greater than negative 3. And I'm going to plug my x in and my y. So let's plug 2 in for x, plug 1 in for y is greater than negative 3. This is negative 8 plus 1 is greater than negative 3. And this is negative 7 is greater than negative 3. Is that true? Correct. That is not true. All right, this is not true. That means this point out here in the unshaded region is not a solution. None of these points are solutions. Now, if you have a dotted line, the dotted line means that is not included in the solution. So let's just be darn sure that we did the right kind of line and that we solved this correctly. So let's pick this point 1,1 is on the dotted line. So if it's on a solid line, it will work, but if it's on a dotted line, it should not work. So let's pick the point 1,1. This is the last point we're doing for this example. So we're going to pick the point 1,1 and we're going to plug it in to our inequality here. So negative 4 times 1 plus 1 is greater than negative 3. Negative 4 times 1 is negative 4 plus 1 is greater than negative 3. Negative 3 is greater than negative 3. Is that true? No, negative 3 is not greater than negative 3. It's equal. So we're going to say, no, that's not right. Okay? All right, so let's use our steps. We're going to do 2 more examples and then we'll be done. So let's go on to your second page here. We're going to graph this inequality, x plus 2y is less than or equal to 4. So go ahead and draw your wall and go ahead and solve for y. Okay, when you solved for y, you should have gotten y is less than or equal to negative 1/2 x plus 2. Okay, second step, you're going to go ahead and use your y-intercept and your slope to graph the points on the line. So go ahead and do that. Okay, so we've graphed our points on the line at 2, and then we've gone negative 1/2, negative 1/2. I can actually graph quite a few points across here using my slope. Just want to make my line more accurate. Then we have to see, is the line dotted or dashed or solid? So look back at your steps, at your symbols. If it has a solid line for equals, that means there's going to be a solid line on the graph. So make your solid line all the way across through your points. And we're going to put our arrows on either end. Last thing we have to do is look at the shading. So looking at the symbol, would I shade up or down? That's right, it's a less than symbol, so I'm going to put my pencil on the y-intercept and I'm going to shade everywhere below that. So I'm going to shade this whole area below the solid line. So again, every point in the shaded area is a solution that makes this inequality true. Since this is a solid line, those points should also make the inequality true, and the points out here in the white area should not make it true. Okay? So let's pick 3 points just to see. I want you to pick the point 5, 5. So it's 5, 5. That's out here in the white area that's not shaded. So pick your point 5, 5. This is the x, this is the y. Go ahead and write down your original inequality just to make sure we haven't made any mistakes here. So x plus 2y is less than or equal to 4. So go ahead and plug your x and y values in and solve. You should get 15 is less than or equal to 4. And that is not a solution. That's incorrect. So nope, that's not a solution. This is correct. It's not in the solution area. All right, I'm going to get you to try 2 more points. This time I want you to try 0, 0. That is in the shaded area. And let's make sure that is a solution. So go ahead and write your inequality again. X plus 2y is less than or equal to 4. Plug in your 0, 0. And see what you get. Okay, when I plug in 0, 0, I'm going to get 0 is less than or equal to 4. Is that true? Yes, it is true. Okay, so that is a solution, so it's shaded correctly. Now, last one I'm going to pick is a point on the line. So I'm going to pick the point, let's just pick the point 2, 1. That's on the line. So here's the point 2, 1. That's my x, that's my y. Go ahead and plug those again into the inequality and see what you get. Okay? You should have gotten 4 is less than or equal to 4. Now, is 4 less than or equal to 4? Yes, it is, because 4 is equal to 4. So is it less than or equal? Yes, it is, because it is equal. So my solid line is right, my shading is right. We've done that correctly. Okay? Last example, and this one is kind of funky. That's why I wanted to put it in here. We don't have y on this one. We just have x. And if you remember, if I just have x and no y in an equation or inequality, I have got to realize that this is a funky line. I can't put x equals into the calculator. I can only put y equals. So our solving for y doesn't work. Remember, if you have x only, this is going to relate to hoi vux. So do you need to think of hoi or vux if you have an x? Right, you're going to think of vux. So remember, vux means vertical. It means the slope is undefined. Okay, and the equation we said was x equals. In this case, it's x is greater than, but we have x is greater than 2. Well, I'm just going to graph that point, x is 2. And then we know it's going to be a vertical line, so I'm not going to graph 2 points. Following my steps, I'm not really going to graph 2 points. You can if you want to, but I know it's a vertical line. So let's go to step 3, which is to determine whether it's dashed or solid. So looking at the symbol, is this going to be a dashed line or a solid line? Correct, it's going to be a dashed line. So I'm going to make a vertical line with undefined slope that's dashed at x equals 2. So let's go vertical line like this that's dashed. Draw my arrows on the ends. Now my solution here is x's that are greater than 2. Are those solutions going to be to the right of this line or to the left? Correct, they're to the right of this line. All the x's that are greater than 2 are over here to the right of this line. Okay? And if I pick any of these x's, let's just pick 5 for example. If I pick 5 and I say 5 is greater than 2, is that true? Yes, it is. So we did in fact shade the correct side. Okay? So that is basically what you're going to be doing today. Let me show you in summary. I have a little chart here that will hopefully be helpful to you. I have my dashed line over here. Dashed line is related to less than or greater than. Solid line right here is related to less than or equal to, or greater than or equal to. These two symbols up here are both less than symbols, so this means shade down. Down. These two symbols down here are related to greater than, so these two symbols are shade up. Okay? And then a couple of other things I want to put on here are just that for these two symbols also, if you are looking at domain and range, or if you're looking at a single variable inequality, these two symbols are also related to the open circle. These two symbols are related to the closed circle. And the only other real rule that you need to remember about inequalities is the rule that we said at the beginning. I'm going to write it over here. Go ahead and write it so you'll have everything in the same place. If you multiply or divide by a negative number, or divide by a negative number, you have to flip the symbol. Okay? So this part down here, this summary, this is pretty much everything you need to know about solving and graphing inequalities. Hope you have enjoyed the video.